Hello everyone, welcome to Code with Raj. So today we would be solving the next question of our top interview 150 series. The question name is remove duplicates from the sorted array. So let us read the question. In the question it is given that given an integer array num sorted in non-decreasing order, we need to remove the duplicates in place such that each element unique appears only once. The relative order of the element should be kept same. Okay. Consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements of k. The first k elements of the num should contain the unique numbers in sorted order. The remaining elements beyond the index k minus 1 can be ignored. So this is the custom judge. We could just ignore it. I can explain you the problem now. So basically, uh, let us understand the problem first. What they're saying is, okay, yeah, okay. So they are saying is basically you are given a nums in a sorted order, and what you have to do is like you need to remove all the duplicates. So let us take this example only. So here nums is equals to 0 0 1 1 1 2 2 3 3 4. Okay, so uh, basically what we need to do is we need to remove the duplicates. So since 0 is coming twice, we could take it 1, and similarly 1 2 3 4. So basically we need to return the number of elements that are unique, and as well as we need to do it in place nums only. So rest of the element can be anything after that, because in the custom judge they will only check this many elements. Okay, so how to approach this question? What is the most basic approach you could think of? So like what we could do is like simply we could maintain a hash vector or a map int comma int. So what we could do is like we could iterate over the whole array. So for int I is to nums, we could just do mp of I plus plus. So this way we would get all the unique elements in the map. It would contain all the unique elements. Then we could create a vector temp, and in that we could store all the elements of mp. So what we can do is for auto it is to mp temp dot push it dot first. So this will create all the unique numbers in the temp vector, and at last we could just return temp dot size. And before doing this we could copy the nums vector, like we could copy the temp vector into the nums, so that in the custom judge it passes. So this is the very like naive approach, you can say. What we are doing is we are just simply iterating and keeping the count of elements. So what is the time complexity? Suppose we are using an unordered map, so big of 1 for accessing the elements. We can ignore that log n complexity normal map. So big of n space time complexity, since we are doing a linear pass, but we are using extra space of this map and this vector, which is roughly about big of n, you can say. So average space and time complexity are big of n, which are not favorable for this type of question, because uh, like this big of n space is not required here. We could also solve this question without using this big of n space. We could solve it in big of 1. So like we need to develop an approach such that we are not using this map or this temp vector, and we are doing in place only. So let us again come back to the sample case and try again. So one thing we could do is like we can see we are not utilizing the property that this array is sorted. Okay, so instead what I think we could do is we could have a pointer here and a pointer here. Okay, I will explain you as we move on. So what we are doing is basically we need to see every time when we have unique element. So if we are not having unique element, we would just move this. And as we found a unique element, we would stop and swap the next position of this pointer with this element. So this 0 will become 1 and this will become 0. Okay, and we will move this pointer again here, and again we will continue the same until we are seeing value 1 on this pointer. We will continue to move here. So again move, and as we found 2, we would swap the next value with 2. So 0 will come here, 2 will come here. So see 0 1 2 we have formed, and we will move this pointer here. Again we will start to move. We found 2, then 3. So at 3 we found that it is different from 2. So again this will come here, and this 3 will be swapped from this. So 3 here and 2 will come here, and we will move this here, and since it is the same, we will continue. And 4, at last 4 we saw there's a different value, again we will come here and swap this with this. 4 and 2 will come here. We don't care about rest of the elements, that what are they, because at the custom judge they are only checking the first k elements, and we will return the value of pointer 1, because that will be pointing at this index only, which contains all the unique elements. So I think this may not be clear using this, but once I write code, this would be clear automatically. So let us jump onto the code editor and start coding. Okay, so let us take int n is equals to nums dot size. We could have two pointer, ptr1 equals to 0 and ptr2 equals to 0. We need to run the loop until ptr2 reaches the last position, because we need to check at least how many elements are there, because there may be elements at the last, so we need to run through whole array. So while ptr1 is for safety, we could just also put ptr1 less than n, and ptr, because there might be a case where all the elements are unique only, so ptr1 and ptr2 will move simultaneously only. ptr2 less than n, we could just do if nums of ptr2 equals to nums of ptr1, we could just do ptr2 plus plus, and in the else case, when we found that the number is different, we would just swap nums of ptr1 plus 1 comma nums of ptr2, and we would do ptr2 plus plus, because the swapped element would be different and we need to check for the same element, ptr2 plus plus. And yeah, this will continue. At last we could return the value of ptr1. I guess this is fine, and it should work. So let us once submit and see for the sample test cases. Okay, so something, oh yeah, I need to like here do ptr1 plus plus also, because once we swap the elements, the ptr comes to the next position, so we need to also do ptr1 plus plus. Yeah, I guess now it should work. ptr1, yeah, so basically what the problem is, this is a very good thing actually. So you can see that this is a tip to notice here also. You can see that we are getting one, like one element is less in our output. Why this is the case? Because basically in this custom judge they are checking the number of elements. So basically our pointer 1 should return the number of elements, but our pointer 1 is actually the array index, so we need to return pointer 1 plus 1, so that we return the total number of elements instead of returning the pointers, the array pointer. Now it should run fine. So yeah, so our test cases got accepted, and you can see, so for debugging purposes, let me print the array also for int I, so you can see that how the swaps are going on. So you can see 0 1 2 3 4, and all the extra elements got swapped and came to last. 0 2 1 3 1, these were extra elements. On the first test case also you can see 1 2 and the swapped element got here, and at last we could just submit the solution, and let's go and submit. So our solution got accepted, and don't worry about this like beats 5.04 seconds, it's always different. Sometimes if I will submit again, it will again change. You just focus on the approach. So what is the complexity of this solution? So this approach only take big O of n time complexity and big O of 1 space complexity. So this is the most optimal approach for this question. Thank you so much for watching, guys, and I hope you like the video. Please make sure to press the like button, and please also press the subscribe button, and make sure to give feedback in the comments what else you want from me, what else you want me to do extra, and like what else do you want me to teach. And the code link will be added soon in the description. Currently I'm working over it. Thank you so much for watching. Bye bye, see you.